Hello student, we are going to see one important topic of the light, that is the refraction of light. Term refraction refer to the property of light. This property of light occurs when it is passes from one optical medium to another optical medium. Suppose it passes from air, one of the optical medium, to suppose water. Then what happens when a ray of light is passes from one optical medium to another? It bends from its path. So this bending of light, when it passes from one optical medium to another optical medium, then this phenomena is called refraction of light. So we may say that the phenomena of refraction of light occurs when it is passes from one of the optical medium to another. Let this green line and red line is here. Red line divides two optical medium 1 and 2. Let it is rarer medium and it is denser medium. Rarer medium you may say air, denser medium you can take glass or water, suppose. So when we compare between both air and water, air is a rarer medium than water. And experimentally it is observed that when a ray of light passes from rarer medium to denser medium, it bends towards normal. See, this is a normal. This ray of light bending towards normal, so this is called incident angle and this is called a refraction angle. Refraction angle is denoted by R, whereas incident angle is denoted by I. This is the experimental observation. Second experimental observation is also obtained if suppose the first medium we take denser medium in comparison to the second. Let this denser medium is water and second medium we take air, it is rarer medium. And a ray of light let angle I incident on the interface of denser medium and rarer medium. Then experimental observation shows that it moves away from the normal. Here angle R, angle of refraction. Now let us compare both diagrams. In the first case, when light is passes from rarer medium to denser medium, bends towards normal. towards normal, and here bends away from normal. Here in this angle of incidence I is greater than R, and here angle of incidence I is less than angle of R. So in the both diagram, light is either passes denser to rarer medium or denser medium to rarer medium. One thing is a common. What is the common? Bending of light, bending from its path. So it's bending from the path. See carefully. Path of light is called refraction of light. So this is time to see the laws of refraction. To see the laws of refraction, see in the diagram carefully. There are two laws of refraction. Two laws. First law, see in the diagram. This is called incident ray. This is normal written here, and it is called refracted rays. So three parts in the first law. The three things are here. First, incident rays. Second one is refracted rays, and third one is normal. Normal means perpendicular to the plane. This both. All these three lies on one plane. This plane is plane of paper here in the diagram. If you see in the diagram, this incident ray, refracted ray and normal all are lies in a same plane in both of the diagram, either bending towards normal or bending away from the normal, but bending is there. Bending of light is refraction. Now we are going to see second law of refraction. Second law of refraction is also known as Snell's law. What is the Snell's law? Snell's law gives the mathematical form. See, actually it's give ratio. This is a ratio. What is the ratio? Ratio between sine of angle of incidence to sine of angle of refraction. Sine of angle of incidence is represented by I, and sine of angle of refraction R. So mathematically, when we want to keep in mathematics, this is sine I, ratio means divide, sine R. It's bare constant ratio. This is called refractive index. Sine of ratio of sine of angle of incidence to sine of angle of refraction bears a constant ratio. See, this is bears a constant ratio. See, this constant ratio is called refractive index. This refractive index is denoted by n, small letter. It is equal to sin I by sin r. Right? When we take in the first diagram here, suppose this is diagram first A. When ray of light is passes from medium number 1 to 2, then it is called refractive index of medium 2 with respect to medium 1. It is written in this form. So 1 and 2 is equal to sin I by sin r. This is the constant ratio. This shows that if we increase angle I, angle R will also increase, and it's vice versa also in both of the cases. But the ratio will not change, and it will depend on the material of the real of pair of medium. We are taking pair of medium air water, water glass or air glass, any one of these. Snell's law takes in a different form. It can written when light rays travel from air to water, it is written as NAW sin I by sin r. Refractive index water to glass sin I by sin r. We may write in this form, so it takes the form. This formula is known as Snell's law. Right? Now see carefully here. Two laws we have seen. One, all three, incident ray, refracted rays and normal, lies at one plane. And second, sine of angle of incidence to sine of angle of refraction have a constant ratio. This constant ratio is called refractive index of second medium with respect to the first medium. There is one more reason, a certain reason is there when no phenomena of refraction takes place. When light passes from one optical medium to another. So see this. Suppose this blue line divides two optical medium 1 and 2. Let this perpendicular line is normal. When a ray of light coming from medium number 1 along to the normal or parallel to the normal given in the diagram. So it transmits the medium. No difference. This transmit in the medium. See carefully. In the same direction. So in that condition, no bending takes place. This is the special condition. It takes place under a special condition when ray of light travel falls normally on another medium. Incident ray, we may write incident ray falls normally. It is called. So in that condition, no bending takes place. We can take one special condition under the law of refraction. See the cause of refraction. Why refraction takes place when ray of light passes from one medium to another? So Huygens theory used to explain. We know in the Huygens theory the concept of secondary wavelets. The propagation of light, the movement of light is due to the secondary wavelets. When these secondary wavelets travel, moves from one medium to another, its speed changes. Change in the speed of light when it passes from one optical medium to another. Why? The secondary wavelets speed changes according to Huygens when it is passes from one optical medium to another. So we may say that the cause of refraction is, we may write in one line, change in speed of light. Change in speed of light in which condition? When it is passes from one optical medium to another optical medium. So we may see here in this diagram, very carefully see. See in the diagram, the first diagram, let in the first medium, which is rarer air is given here, let its speed of light is c1 and in second medium c2. So this c1 and c2, when it is changed, moves from rare to denser medium, we may say that the speed of light becomes slower when it is passes from rarer to denser medium. So it's become, see very carefully, slower when it passes from air. In the second diagram, when it's moved from water to air, denser to air, the speed, let here velocity is c1, here c2. So it, when it is traveling rarer medium and comes from a denser medium, its speeds become faster, more velocity. Due to change in the speed of light, velocity of light, change in the direction occur. This change in a direction or bending of light is called refraction. So under these circumstances, the Snell's law, which is a ratio between sine of angle of incident to sine of angle of refraction, takes a form in this way. See, it is refractive index. Refractive index, its N, defines as the ratio of, see carefully, speed of light in first medium to speed of light in second medium. So, and let speed of light is, first medium is c1 and in second medium c2. This is refractive of second medium with respect to first medium. So Snell's law can be written in this form also. Let this is equation number 2, and here in the first case Snell's law is represented by equation number 1. So this is called Snell's law. This is all about the refraction of light. We hope we enjoyed well. This is for only the topic. Thank you and have a nice day.